Let's explore how touchscreens work and the technology that detects your touch. Touchscreens serve as both input and output devices, layered on top of visual displays like LCD, AMOLED, or OLED screens. A touchscreen consists of three key components. The touch sensor detects your touch, the controller processes the location of that touch, and software drivers allow the device to interpret this information. Resistive touchscreens use two layers of electrically conductive material separated by a small gap. When you press the screen, these layers connect, completing a circuit. One advantage of resistive screens is that they can be operated with any object, not just a finger. Capacitive touchscreens use a different approach. They feature a transparent layer of conductive material that creates an electrical field. When your finger touches the screen, it disrupts this electrical field. Sensors detect the change in capacitance at the specific location of your touch. Unlike resistive screens, capacitive technology requires a conductive object like your finger to work, which is why gloves can prevent touchscreens from detecting your touch. Today, capacitive technology dominates the touchscreen market, powering approximately 90% of all touchscreen devices worldwide. This dominance is due to capacitive screens' superior sensitivity, accuracy, and responsiveness compared to other technologies. Surface acoustic wave technology uses ultrasonic waves to detect touch. Transducers emit sound waves along the sides of the screen, which are reflected by wave reflectors. When a finger touches the screen, it absorbs some of the acoustic energy, which is detected by the receivers. SAW screens offer excellent clarity and durability, making them ideal for public displays. Infrared touchscreen technology works quite differently. IR screens use light-emitting diodes and light detectors to create an invisible grid of infrared light beams across the screen. When your finger or any object touches the screen, it interrupts these light beams, and sensors detect exactly where the interruption occurred. A key advantage of IR technology is that it works with any object, not just human fingers, making it ideal for industrial applications. The touchscreen market is experiencing substantial growth, driven primarily by mobile devices. According to market research, the global touchscreen market is projected to reach nearly $42 billion by 2032. This represents a compound annual growth rate of 12.54%. This chart visualizes the dramatic growth expected in the touchscreen market over the next decade. Among the most exciting current trends are foldable and flexible displays. These innovative screens can be bent or folded, offering larger screen real estate in compact form factors. Haptic feedback technology is becoming more sophisticated in modern touchscreens. Advanced haptic systems provide more nuanced and realistic tactile sensations, enhancing the user experience by adding a sense of touch to digital interactions. Transparent displays represent another cutting-edge trend in touchscreen technology. These screens enable augmented reality applications by allowing users to interact with virtual objects overlaid onto the physical world behind the display. Looking to the future, touchscreen technology will continue to evolve in several key directions. Future touchscreens will focus on greater versatility, affordability, and durability to serve an expanding range of applications. We'll see deeper integration of artificial intelligence and machine learning, enabling screens to predict user intentions and adapt to individual preferences. Advanced gesture recognition systems will allow for more intuitive interactions, including touchless controls. Haptic feedback will become even more sophisticated, potentially creating the sensation of different textures for virtual objects. And as public health concerns continue, self-cleaning surfaces with antimicrobial properties will become standard in many touchscreen applications.